Yes, today we are going to start the revision of formula and stoichiometry. For this, we have opened the revision checklist. So if we see first point in formula, state the formula of the element and compound name in the subject content. Yes, for example, if we see for element, it is O2, H2, these are the molecule of elements. So their formula is O2, H2, Cl2, same for all halogens, I2, Br2, N2, even for phosphorus, it can be P4. Okay, if we see the formula of a compound, for example, very simple in our use is H2O, water. In simply, we can say the formula is the symbolical representation of a compound instead of the writing of whole name. And define the molecular formula of a compound as a number of and type of different atoms in one molecule. Okay, what is this? Actually, the molecular formula is the formula which show exact number of atoms in a molecule. For example, C6H6. For example, for glucose, it is C6H12O6, means all number of atoms in a molecules are given. In contrary to it, if we see in reference to empirical formula, empirical formula is the formula which show the simplest whole number ratio of the atoms in the compound. For the same molecule, for the same compound, I would like to show you empirical formula. For example, empirical formula for this above compound, which is benzene, is CH, and for glucose it becomes CH2O. That is simplest whole number ratio. Same like for hydrogen peroxide, H2O, this is molecular formula and this is its empirical formula. Hope you understand what is meant by molecular formula and what is meant by empirical formula. The empirical formula of a compound as the simplest whole number ratio. The one thing which is need to be remembered is whole number ratio, not in points or in fractions of the different atoms or ions in a compound. I would like to show you this formula from the past papers or question papers. If we see in this compound, yes, it is shown here in P1. Yes. If you see in this 10th MCQs, in 10th MCQs, he is asking actually. Yes. In 10th MCQs, he has given the percentage. Okay, how to calculate empirical formula? To calculate empirical formula, percentage of each element is given, or mass of each element is given. Their percentages should be divided with their AR. I am saying here AR, not MR. So 70% is iron, its AR is 56. And same way, oxygen is 30%, its AR is 16. Wrongly, student used to put 32. 32 is MR, that is mass of its two atoms. In the molecule, there are two atoms. So we have to place here AR, not MR. So AR is 16. If we calculate it, it becomes 1.25 and it become around 1.875. Okay, now we will see the smaller answer to find the ratio between these two atoms, or if three atoms. In this case, there are just two atoms, 1.25, and this is 1.25. It becomes 1 and it is 1.5. So it is not whole number. To convert it into whole number, we have to multiply it with a suitable integer. We have to start it with a smaller integer first. So the smallest integer with which we can multiply is 2. So it become 2, iron become 2, it become 3. The answer is Fe2O3. So this is the right answer. Hope you understand how to calculate empirical formula. Again, I'm revising here. You will be given the percentage or mass of each element. With the help of percentage or mass of each element, you will divide this percentage with the AR of this specific element. After calculating this, you will get the answer. See the smallest answer. Divide all answers. If 2 or 3 or 4, in this case, there are 2 answers. Divide all answers with the smallest answer. You will get the ratio. It may be not in whole number. If it is not in whole number, you have to multiply it with a suitable integer to convert it into a whole number. In this very specific example, it is shown you. Okay, if we see learner guide again, our revision checklist. In revision checklist, next point is student should know define the empirical formula. Yes, the formula which shows simplest whole number ratio between the atoms of a compound. Deduce the formula of a simple molecular compound from the relative number of atoms or ions present in a model or diagrammatic representation. Okay, for this specific, they will give you a suitable information regarding this. For example, this is the diagrammatic representation in this very specific. What he is asking, what is a part of the structure of zinc sulfide is shown below. Zinc ions are dark dots, and sulfur ions are hollow or white dots. Deduce the empirical formula of zinc sulfide from this structure. So what is the empirical formula? The empirical formula is 1 2 3 4 5 6 7 8 9 10. Okay, same way, 1 2 3 4 5 6 7 8 9 10. So both are 10, both have same number. Instead of writing Z and 10 as 10, this is not empirical formula. We have to write it Z and S. This is the right formula, zinc sulfide. To explain, I have written here, the actual answer is this one, zinc sulfide. Hope you understand how you will give the answer from a diagrammatic representation. Sometimes students are not able to understand this, how we can calculate or how we can represent molecular or empirical formula of the diagrammatic representation. Hope it is clear to you. Now, I'm going to next point of the revision checklist. Construct word equation, symbol equation, and ionic equation to show how the reactant from product including state symbols. Okay, with the help of suitable examples, you can deduce the ionic equation or suitable equation. For example, this equation is given. I would like to search such type of question in which he is asking for the okay, here it is not giving the equation. Okay, hope I will show you next. Deduce the symbol equation with the state symbols, relative mass and molecular mass. Okay, from this another thing I would like to explain one more thing. Representation, if the suitable ions, number, atoms are given. In this very specific example, if you see in this question, yes, in this very right question, he's giving the MR of oxygen is O2 is 32 and the MR of sulfur is 256. What is the formula of the molecule of sulfur? Okay, why he has given you the example of 32? 32 is its MR. To see the total number of atoms in a molecule, in the formula of a molecule, we have to divide it with its AR. It's become 2, so the molecular formula is O2. In the same case for sulfur, it is 256. If we divide 256 with the AR of sulfur, which is 32, we will get the answer 8. So the right answer is S8, this one. This is a wrongly placed tick. This is not right answer. This is the right answer. Okay, which molecule has the largest number of electrons in the covalent bond? Okay, We have done this in covalent bonding, but for this specific question, you have to draw the displayed formula. For example, CH3OH. In previous video, I have shown it. We discussed it. Okay. If you see how many covalent bonds are there, 1, 2, 3, 4, 5. Largest number of electrons involved in covalent bonding. So 1, 2, 3, 4, 5, 5 twos are 10. In each bond, there are 2 electrons. So 10 electron in total in this. If we see in this example, C double bond and H, 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 and H. 1, 2, 3, 4, 5, 6. 6 twos are 12. Here, 12 electrons involved in bonding. So, from this, you can conclude which have in carbon dioxide, there are 4 bonds between carbon and oxygen. Between one oxygen and carbon, there are 2 bonds, and other are also 2 bonds. In total, 4 bonds. 4 twos are 8. 8 electrons involved in bonding. Here, 10 electrons are involved in bonding, and in this case, N triple bond N, again 3 twos are 6. 6 electrons involved in bonding. So it is 1, 2, 3, 4, 5, 6. 6 twos are 12. The largest number of electron involved in bonding in the case of A. Hope you are clear how to see the shared electron. And next, element X has the electronic structure. Yes, from the electronic configuration, how you can determine the molecular formula or the empirical formula of the compound. It has 5 electron in its outer shell. It has 7 electron in its outer shell. So if he asks what type of bond they will form covalent bond. This is a covalent compound, covalent molecule, not ionic compound. For ionic compound, one should have the electronic configuration of metals. In metallic electronic configuration, there should be 1, 2, or maximum 3 electrons. So in both cases, there are not 1, 2, or 3 electrons, so they will form covalent compound. So if we see in this case, it requires 3 electrons to fill its outermost shell, like noble gas, that is 8, and it requires 1 electron. Okay, so what will be the formula? The element which requires 1 electron should be 3. These should be 3, and X, I think so, should not think so, must be X should be 1. For example, X has 5 electron in its outer shell. I would like to show you these 5 electrons. These dots, this dot, this dot. Okay, 5 electrons. So this has 7 electron in its outer shell. 1 of 7 is here. So it will form a covalent bond with it. Okay, Y's electronic structure is completed. After sharing 1 electron, it becomes 8. But still for X, it is 1, 2, 3, 4, 5, 6. Not become 8. Again, another Y atom. I'm explaining in detail so that you can understand. And again, for it, it is again one other. So Y3 X is 1. So it is XY3. Hope you understand how to determine molecular or empirical formula with the help of electronic configuration. Here, very above question, it is also helpful for you. The table gives the arrangement of the electrons in the atoms of 4 different elements. Which element does not form an ionic compound with the chlorine? Okay. So, what it could be? 1 electron metal, form ionic compound. 1 electron, again it is metal. 2 electron, again it is metal. So this is 4. It could not be a metal, so it will not form ionic compound with chlorine. Chlorine is a non-metal. When it react with metals, it will form ionic compound. Hope you are clear with it. Again, I would like to show you Rivian checklist. In Rivian checklist, describe relative atomic mass AR of the average mass of the isotopes of an element compared to 1/12 of the mass of carbon 12 isotopes. Okay, I used to say Carbon is a reference element, is a reference balance for the elements to measure the mass of the elements. So if we want to explain or define what is relative atomic mass, mass of an element, mass of an atom, which is compared with 1/12th mass of carbon 12 isotope. For example, for oxygen, it is 16, 1/12th mass. Which carbon? There are two carbon, carbon 12 and carbon 13. These are isotopes. So which isotope is standard for referencing? It is carbon 12. So in definition, describe relative atomic mass AR as the average mass of isotope of an element compared with 1/12th mass of an atom of carbon 12. Same for molecule. Define relative molecular mass MR as the sum of the relative atomic masses. Relative formula masses will be used for ionic compound. Yes, for ionic compound, I already explained in ionic bonding. We will not say it is a molecular formula or molecular mass. For ionic compound, we will say formula mass instead of writing molecular mass. Molecular mass is only used for covalent compound. Hope you understand. From this checklist, in next video, I will explain whole calculation of moles, Avogadro number. So next video is very important. Must check next video. See you in next video.